Hi, and welcome to training video number 3. This is a video where we're going to discuss the details on plate solving and how to use that procedure to locate your target. And tonight we'll be using the Station 3 telescope. So I'm going to go ahead and share my screen here, and we are already connected to the observatory. And this is the screen that you'll see when you connect in. We've covered the process of connecting in and opening the software in previous videos 1 and 2. So if you want to reference those, if you're unfamiliar with or unsure of how to get to where we're at right now on this screen. So we'll want to go ahead and notice that the webcam in the observatory shows the telescope is in the home position, which is good. That's where we want to start, and that the roof is off. You can see stars there. So we'll go ahead and minimize that software now, since we know the telescope appears to be where it should. Now I've offset the telescope a little bit from the park position so that when we do slew to our target, which is going to be M1, it will probably not be on the chip in the field of view. So we'll have to use plate solving to get there. So let's go ahead and do that. So opening cart to seal and connecting to the telescope, which we've done, and then putting into your search window the target M1. Let's go ahead and do that. And when we hit enter, it should put M1 in the view. There we go. So to slew to that, you just right click on M1 icon in the view there, and the telescope tab opens up, and just go on over to slew to M1. Well, it doesn't show M1 because I must have clicked on a star right near M1. Let me try again here. There we go. Let's go back here now, slew to M1. All right, here we go. Telescope is slewing. Eventually we'll see the telescope icon, the tracking telescope window, move over to the M1 in the center of our chart here. And we can also watch the telescope move by just looking at the webcam. And we should see the telescope moving. That looks good. Okay, everything appears to be doing well. Let's go back to our star chart, and there we go. We see the circle of our telescope moving on to the center of where M1 is. Okay, so the software thinks we're on the target right now. So we're probably not, because as I say, I did offset the telescope a little bit before I started this training video from the home position so that it will not be on the target, so we can demonstrate plate solving. So let's go and do that. So let's take a picture. So we go to the camera control window, expose tab, and I'm binning 2x2 right now. Plate solving works a little bit better. Initially, if you bin 2x2, it's a little bit faster. And so I'd recommend when you're using this telescope with the color camera, which is the one that we're using tonight that's attached to this telescope, is the 178C, and we're using the 102 carbon fiber Explorer Scientific refractor for this imaging session tonight. And we'll see an image pop up here in just a second. Okay, very good. So there's our image. Move this out of the way so we can see it a little bit better here. And let's go to get to the full frame. I like to go down to 50%. That'll show us the full. And as we expected, M1 is not in the field of view. So what we have to do now then is plate solve. So let's show you how to do that. So you go to, under MaximDL, go to Analyze, click on the Analyze tab, click on Pinpoint Astrometry, and technically you should be able to just hit Process and it should plate solve. So let's go ahead and do that. But it probably won't, and that's because sometimes when your telescope is far enough off the target, it just takes the software longer to solve the position, and you don't have all night to wait. So if it doesn't solve within about 30 seconds or a minute, then I'd recommend clicking the stop button and going to Search Sky Online and letting astrometry.net take over. So that's what we're going to do here. So because I'm pretty sure it's not going to solve within the next few minutes. So let's say you've been sitting here and it's been a minute and it hasn't solved. So go ahead and click stop. And then notice Search Sky Online window lights up. And let's go ahead and click on that. And what you'll see here now is the software will start pretending like it's solving, and then you'll see the little red X light up at the top there, which might be worrisome, but it really isn't. I know that that's just a normal thing that MaxMDL does when you send an image to astrometry.net. Now, it typically takes a couple minutes to get your result back. And I thought about maybe pausing the video during that time, but it might be instrumental just to kind of sit here and just watch and see how long it takes as well. And that way you kind of get an idea about when you're actually doing this yourself, how long you should expect it to take. So we're going to go ahead and just let it do its thing here and see if it comes back with a solution here quickly. I'm in a rocking chair, by the way. That's why I'm moving back and forth. It's a very comfortable chair, but if you lean back too far, sometimes you can fall over. And hence we call it the death chair. But if you don't go back too far, you don't die. It's set up really nicely near my computer, so I like to use it. Okay, so should be solving momentarily here. There it is. Okay, so now you notice at the bottom it says, please click process for an accurate plate solve. So we'll do that. Go over and click process. And now we should see a successful plate solve in our window here. There it goes. That's about how long it takes. That's about right. So it gives you the right ascension and declination of the image center, and also gives you the position angle of your camera, which up in our camera right now is 170. So we're about 9 degrees off of due south, looking straight up in our image. Our image is south up approximately. And our focal length of the telescope is 699 millimeters, and we're operating at about 1.42 arc seconds per pixel. That all sounds about right. So what do we do with that? Okay, so what we do with that is we go over to the observatory window and click on the telescope tab. And then there's a little telescope coordinate box that pops up, and there's a sync button. Click on the sync button. And then there'll be one more window that says sync telescope to the coordinates that were determined. We want to do that. Yes. So click on OK. So that's it. So now we should be able to go to our star chart, cart to seal, and it will have on there the position of the telescope and the position of M1. So we should be able to now, if we can zoom out a little bit. Let's just see how close we were to M1. Okay, so you notice our telescope position is to the lower right, as denoted by the white circle, and our target is at the upper left, and they're not lined up. So obviously we are off a little bit. So we should now be able to slew to M1 simply by, again, highlighting M1 in our search field there, right-clicking, going up to telescope, and click slew to M1. And we should now see the telescope move over to M1. Okay, so if all goes well, we should be on our target now. So let's close that window out, and let's take another image. Go to our camera control window. We can probably close out our plate solving window. And let's take a 20-second exposure. All right, here we go. Hopefully we'll see M1 on our chip. M1 is only about halfway up the sky right now, and it's in a fairly light polluted part of our sky here, so the image probably isn't going to be spectacular, but we should be able to see it. And there it is. The sky is a little bit hazy. We're expecting clouds moving in earlier and a little bit later, maybe even some snow by morning. But so that's it. So that's how you plate solve. So now we're on our target. And what we would do now would be to refine the focus and to set up an autosave sequence. That will be the subject of a video in the future. So At this point, I'd like to thank you for watching and look forward to meeting again online here at some point. And we'll learn how to focus the telescope and how to set up an autosave sequence of images so that you can begin capturing the wonders of the night sky. Thank you, everybody, for watching, and have a good evening.